All right, so let's talk about interest. There are two types of interest. What is interest? Interest is money paid for money borrowed or loan. It is money paid for money borrowed or loan. So let's say, for example, Aiden came to me and said, Miss Stampley, can I borrow $100? Right? And I would say to Aiden, okay, there are some terms behind this because I need my money. So it can't be a situation where you borrow $100 from me and then 5 years from now you just bring me back $100. I want money for my money that you borrow, right? So what do I say? Okay, Aiden, you can borrow this money from me for 3 years, right? And I'm charging you 10% interest. The rate is always a percentage, right? So I'm charging you 10%. What does that mean? That means you're going to pay me 10% for every year that you borrow my money, okay? And you can pay me back. The funds will be at maturity, or this loan will be at maturity. What does mature mean? Mature means to grow up, right? So maturity is a word that we use when we're saying that the loan has reached its full term. So the loan will reach maturity at 3 years, right? Which means at the third year, you owe me my money back. Is everybody clear? Does everybody understand that? Yes? Okay. So we got two types of interest. One interest is called simple interest. And it's just that. It's simple. It's very simple, right? What does simple interest look like? So I want us to use the formula that's on our reference sheet for simple interest. Everybody grab your reference sheet real quick. And I want you to tell me, I want you to look at the bottom of the reference sheet. If we look down here at the bottom, we see on the left we have simple interest. And on the right we have what kind of interest? Compound interest. So let's start with simple interest. Simple interest, the formula that they have given us is A equals P times 1 plus RT. What does that mean? A stands for the amount of money that you're going to have to pay me at maturity, right? So when the time comes after those 3 years, Aiden is not going to just give me my $100. He's going to give me my $100 plus whatever he owed me in interest all at once. Is everybody with me? That is called our amount due, okay? Now, what does P stand for? P is the principal. What is principal? It is the amount of money loaned or the amount of money borrowed. In this case, what is the principal? It's $100, right? And then 1. Why is 1 in this formula, Timothy? 1 is in this formula because that means all the money. So he's going to have the principal that he borrowed. He's going to give me all of my money back plus the interest. Well, what is the interest? The interest is the rate times the time. That's the 10% for 3 years. Are y'all following me? Is everybody following? Yes? What happens if he gives me 10% each year for 3 years? What total percent is he going to owe me? 30. So this is going to come out to be 30. Are y'all with me? Not $30, but 30%. This is 100%. The number 1 means all of something, whole, right? So that's 100%. So watch this. Make this make sense. He's going to give me all of my money back plus 30 more percent. Are y'all following me? Yes. Does that make mathematical sense? Yes? All of my money back plus 30 more percent. Now, what does that look like? I'm going to show you that. So before we use the formula, I want us first to just consider this in a table. So make a table for me. And here we're going to put years. And then we're going to put amount. Because this is going to be the amount due. So at the beginning, the initial value. How do I know that's an initial value? Because my x is 0. Are y'all with me? It's my starting point. What is my starting point? What is Aiden's starting point? $100. Does that make sense? Yes? Now, How much interest am I charging Aiden? I'm charging him what?
10%.
10%. So I'm going to charge Aiden 10%. Grab your calculators for me real quick. I want you to get practice with how we put this in the calculator. All right, so in our calculator, we're charging Aiden 10%. So we're going to put 100, do what I'm doing, times 10%. I'm going to put 10. And then where do you see the percent key?
I'm above 2.
Above 2. So I'm going to put second, hit that 2. That just made my 10% a decimal. Y'all see that? And then I'm press equal. What is that?
10.
What is that? 10 what?
Dollars.
So 10% of $100 is $10. So what does that mean? That means Aiden is going to pay me what? $10 every single year. Right? So he's going to give me $10. I'm just putting this off to the side so we can see it. Okay? So at year 1, at the end of the year, Aiden's going to give me $10. So what is Aiden going to owe me at the beginning of this next year? $110. Is everybody following? Does that make sense?
Yes.
Yes? Well, let's do it again. Because Aiden is not just holding my money for 1 year. He's holding it for 3 years. So how much is Aiden going to owe me at the beginning of year 2?
120.
120. Is this simple or is this complex? Simple. Why is this simple? Because it's the same amount of money every year. What do we know about where the same thing happens over and over again? That is a linear function. So guess what simple interest always is? Linear. Why is simple interest linear? Because it's the same thing happening over and over again, right? So here we go. Year 2. $10. It don't matter. Why? Because that $10 we charging him is always based on the initial amount that he invested. Or that he borrowed. I am only charging him interest on the money he borrowed. That's it. Are you with me? So simple interest says, hey, how much are you borrowing? 10% of that. That's going to be $10. So every year, it doesn't matter how much money you owe me, right? Because at the end of year 1, he owes me what? At the beginning of year 1, he owes me 110. At the end of year 2, he owes me what? 120. So it doesn't matter how much he owes me. I'm not charging him on 110. I'm not charging him interest on the extra 20. I'm only charging him interest on
The money
that you initially what?
Yeah.
Borrowed. Are you all following me?
Yes.
So here we go. Year 3
130.
is going to be what?
130.
So at maturity, how much money is he going to owe me?
130.
$130. Does that make sense?
Yes.
This is simple interest. Simple interest says, hey, we charge you the same amount over and over and over again. Why is that? Because we are only charging you based on the initial amount that you invested or borrowed. Is everybody following? Do we charge you on the interest? Do we charge you on the interest? Do I charge you interest on the extra $10? Did I charge you interest on the extra $20 you owe me? No, I only charge you interest on the initial value. Yes.
Is it always going to be 10%?
No. Good question. Will it always be 10%? No. It may be 5%. It may be 3%. Maybe 36%. Credit card companies charge you like 29, 30, 35% on your money, right? So no, it won't always be 10%. I'm just using this because this is an easy number for us to work with right here. Okay? Do we understand how we just got this? Does this make sense?
Yes.
Why do you think we call it simple interest? Why is it simple? It's a linear function. It's the same thing happening over and over again. It's very simple, right? Once I figure out how much interest you owe me every year, I just keep using that same amount every year. Watch this. This is going by 1, right? Everybody agree?
Yes.
Imagine this being a table. Then what happens here? What's the change here?
Change.
Increase by 10. What's the change here?
10.
Increase by 10. What's the change here? Increase by 10. This is a linear function. Why? Because the first difference is constant. Same thing we've always known. Any questions? So if somebody were to ask you, which they will, such and such wants to find simple interest on 13 point some percent loan, blah, 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 blah. What type of function is this? What kind of function is it? Always linear. Simple interest is always linear. Here's the other way we know it's linear. I want you to look at this. How do we determine if a function is linear, quadratic, or exponential? So we look at the equation. We look at the exponents in the equation. Remember, exponents are those superscripts, right? Those little numbers that are up top, right? If there is no exponent, what's the imaginary exponent? 1. What kind of function is that? Linear. Linear functions are one-dimensional, just like this string. They are one-dimensional. Are you all with me? So if I don't see an exponent in an equation, Guido, if I don't see an exponent in an equation, then what that tells me, Alex, is that that equation represents a linear function. If I were to graph it, it's going to give me a straight line. Why? Because somewhere along the way, there is a constant rate of change. Are you all with me? This is constantly increasing by $10 per year. Are y'all following me?
Yes.
Not going to change. Okay? Now, how do I know that a function is quadratic? Right? Matter of fact, yes. How do I know that a function is quadratic? Because when I look at the exponents, the highest exponent is a 2. Quadratic functions are two-dimensional. What does two-dimensional mean? That means you have 2 different measurements. Are you guys with me?
Yes.
Where else do I see two-dimensional? What I'm talking about, like area. How do you find area? Area is
Base.
length times width or
Base.
base times height. Aren't you multiplying 2 things?
Yes.
What's feet times feet gonna be? Feet squared. What's inches times inches gonna be? Inches squared. Well, what is that gonna give me? It's gonna give me an exponent of a 2, which means what kind of function is that? Quadratic. So if you got area, then you are talking about a quadratic function. Why? Because it's two-dimensional. Are y'all following me? Is everybody listening?
Yes.
So if somebody say, Alex was trying to find the area of this garden, right? Here's his base, here's his height, or here's his length, here's his width. What type of function is represented? Well, if you give me looking for area, area is two-dimensional because you're doing a base times a height. Something's going to be squared. That means this is what type of function? Quadratic. Is everybody following? On the flip side, what if we were looking for the perimeter around the garden? Are we multiplying? No. So is that one-dimensional when you're just looking for the area, the distance around the perimeter, or is that two-dimensional? 1. Length plus length plus length plus length just gives you length, right? From here to here, plus from here to here, plus from here to here, that's just length. That's not square, right? 3 feet plus 5 feet is just 8 feet. It's not 8 feet squared. So therefore, perimeter, which is just distance, is one-dimensional. It's linear. But area, which is two-dimensional, is quadratic. Are you listening?
Yes.
Yes? Write it in your notes. What are we writing? We're writing that area is two-dimensional. So it's going to be quadratic. And perimeter is just length. So it's one-dimensional. So it's going to be linear. Does that make sense? Does everybody understand why I'm saying that?
Yes.
Yes? Okay. So area is quadratic and perimeter is always linear. Now, I want to look a step further. Everybody good on that? Now let's jump back here. I want to use this formula that we have from the reference sheet in order to find this same amount. Sit up straight. Stay with me. Here we go. We got area equals, do what I'm doing, P times 1 plus RT. Looking at this formula, this is the formula for simple interest. Simple interest is what kind of function? Linear. How do we know it's linear just by looking at it? The highest exponent is a 1 because I don't see it, right? So let's plug in what we got. What does this A mean? It's the amount of money that Aiden is going to owe me at the end, at maturity, right? What does P stand for? What's his initial value?
100.
Times 1 plus. What was the rate? What is the percent that I am charging him?
10.
So what if I don't know what 10% looks like as a decimal? Because you can't put 10% with a percent sign in here, right? So what do we put? 10. Then I'm going to hit what? Second. And then I'm going to hit 2. And then it gives me what 10% looks like as a decimal, which is 0. What? 1. Now what am I doing with that rate? I'm multiplying it by the what?
Initial value.
What's that T?
Time.
P is our initial value. What's the T? Time. What does that time mean?
3 years.
How long he's keeping my money? How long is he keeping it?
3 years.
3 years. So here I'm going to put a 3. Is everybody with me? Yes? Now, let's grab our calculators. Now we just jump into what we know, PEMDAS, the order of operations. Parentheses, exponents, multiplication, division from left to right, addition and subtraction from left to right. I don't have no exponents, right? Parentheses I do have. I need to work this. So before I deal with this 100, I got to work what's inside here, right? But I got addition and I got multiplication. Which one am I going to do first?
Multiplication.
Multiplication. What's 0.1 times 3?
0.3.
Good. 0.1 times 3 gives us 0.3. So now I'm going to have 1 plus 0.3. What does that 0.3 really represent? What is that?
30%.
Is that, is what?
30%.
It's 30%. It's the 10% each year for 3 years gives us what? 30% total that he's going to owe me. Does that make sense? All right. So now when I take a whole 100%, and I add 30%, what am I going to end up with?
1.3.
1.3 or 1.30, which is 130%, right? So now we got A equals 100 times, I'm adding my 1, and we got 1.3. Is everybody with me? Any questions? So now, let me ask you something. Based on this growth factor, is this, or I just gave the answer, is his money going to grow or decay?
Grow.
Why is it growing? Why is the amount growing?
Because there's a larger size.
Because this is a number that is bigger than 1. What if this number would have been 0.8? Would that be growth or decay? Decay. Because in order for something to stay the same, it needs just to be a 1. But if it's bigger than a 1, that means the number is growing. The initial is growing. And if it's less than a 1, then that means the initial is decaying. Even though it's a 0.8, 0.8 is smaller than 100%. It's 80%. So that means it's decreasing by 20% each time. Y'all with me? So what do we do now? It's our last step. A equals 1.3 times the $100 you owe me, which gives what? 130. What is this 130? The amount of money he's going to owe me at maturity. So here's how I write that. Back to the math. After 3 years, Aiden is going to owe me $130. You can take anything and make it an ordered pair so we can work with it. Are y'all following? Are there any questions about this? Does this make sense? Yes? All right. So, what kind of interest is this? Simple. Wasn't it simple though? We had 2 ways of doing it. We could have either made us a table, right? Because we knew how much it was increasing by each year, 10% of $100. Same amount every time. Or we could just plug these numbers in, where this is our initial value, this is our percent, and this is the amount of time he's keeping the money. And algebraically, we can solve it to figure out how much money he's going to owe us after the 3 years. Are there any questions? Here's my question to you. Are we charging him interest on the money he borrowed only, or on the money he borrowed plus the interest that he accrued over time? Only the money he borrowed. How do I know that? Because it's $10 the same every single time. Otherwise, wouldn't it be 10% of 110 and 10% of 120, right? Because don't he still owe me this money? Yes? All right. Let's look at compound interest. What is the formula that we have for compound?
A equals P times 1 plus R over N.
A equals P times 1 plus R over N times NT. And let me talk about all these parts. When people charge you compound interest, they don't charge you once per year. Are you all following? They may charge you quarterly or monthly or semi-annually, which means every 6 months because it's twice a year, right? So what do you tend to see in compound interest? Let's say, for example, I come to Aiden and say, Aiden, I'm going to charge you, instead of simple interest, I'm going to charge you compound interest. And I'm going to charge you interest every
4 months.
Okay, so if I do it, well, traditionally it's every 3 months because it's quarterly, right? So if we take 12 months and we divide it into 4 quarters, right? Then that gives us 3 every 3 months, right? So let's say I tell Aiden, I'm charging you quarterly, okay? So that means this number down here is gonna be a 4. Why? Because I'm charging him 4 times a year. Are y'all with me? So let's say, for example, if it was 12%, 12 divided by 4 means I'm charging him 3% the first time, another 3% the second time, and 3% another time, 3% the other time. So that when you add up all 4 of those 3%, it come out to be a total of 12% at the end. Are y'all with me? Mm-hmm. So this number is the number of times that I'm charging you over the year. What if I charge you semi-annually?
Every 6 months.
That's every 6 months. So what am I going to put here? A 2. Not a 6, because I'm not charging you 6 times. How many times do I charge you? If it's semi-annually, I only charge you twice. It is every 6 months, but I only charge you twice because I'm only pulling it twice, right? So this will be a 2. So then it'll be, if it was 12%, it'll be 6% the first time, and then another 6% the second time, right? So what this does is it breaks the interest rate up into the number of periods, so that you're not charging 10% every time, but you're breaking it up so you're charging a little bit of that 10% each time, or 12%, okay? So let's look at the same scenario. Let's say Timothy came to me and he said, Miss Stampley, I heard that Aiden borrowed $100 from you. Can I get $100? Like, yeah, but you gotta pay me back. You're gonna be like, okay, you gonna give me the same terms that you gave Aiden? Yeah. So you go talk to Aiden. Aiden say, oh yeah, she charged me 10%. And she said it's due in 3 years. So then he comes back and say, okay, Miss Stampley, I would like the money for 10%. Can you give me 10% interest? Like, yeah. Nothing less than 10. Nothing more than 10. No problem. And I'll give it back to you in 3 years. No problem. So essentially, when he talked to Aiden, he's like, hey, she gave me $100. She gave me $100. She only charged me 10%. She only charged me 10%. Well, I got to pay mine back in 3 years. Me too. So he feel like, hey, I'm getting the same situation. But what he don't know is that I'm charging you simple interest and I'm charging him compound. On the surface, it looks alike, right? I'm only collecting interest once from you. I'm only going to collect it once from you. But here's how it's different. So at the beginning, it's how much? $100, right? Y'all with me?
Yes.
After year 1. So if I'm charging him 10% for 3 years, let's see how it looks. 10% of $100 is how much? Come on, we already figured it out. 10. So that means at the end or the beginning of year 1, or at the end of year 1, he owes me what? $110. Everybody agree?
Yes.
Is this the same or different from Aiden?
Same.
It's the same. At the end of year one, 110. At the end of year one, 110. Right? No difference. He's like, I don't know. Miss Stempley gave into that way too easy. Let me go check with Aiden. Aiden, how much you owe Miss Stempley at the end of year one? 110.
Mm-hmm.
Me too. Okay, I'm good. I'm good. She charging me the same thing. No worries. Let's go to year two. So I'm here now. I'm at the end of year one. Grab your calculators. What are we gonna do? We're gonna do 110. And what percent am I charging him every year?
Same.
So we're gonna put times 10, and then we're gonna hit second and 2, right?
0.1.
And then we're gonna press equal. What do we get?
11.
What? Let's do it again.
We start at 1.2.
How much?
We start at 1.2.
110 times 10 second percent equals. What do we get?
11.
Why are we getting $11 now?
Because
Because now I'm charging you 10% on what? On the 110. So now here, $11 you owe me in interest. Are y'all following me? So now, what is he gonna owe me at the beginning of year two?
121.
100 and what? $21. Is that the same or different from Aiden?
Different.
Different. Not that much, but it's different. Why? What am I doing to Timothy that I did not do to Aiden?
You did.
I'm charging him interest on what? On the interest and the principal. I'm charging him interest on everything you owe me because he didn't come to me and say, Miss Stampley, I'm just going to give you your $10 I owe you right now. At the end of year two, come back and I'm going to just pay you your interest. Because if he gave me the money he owed me at the end of year one in interest, then I would just be starting back at $100 again. Right? But he didn't do that. He let his interest accrue. So he said, nah, I'll just pay you the interest at the end. No problem. Because when you pay me the interest at the end, now you're going to pay me interest on the interest. That's how simple interest is different from compound interest. Simple interest, we just charge you interest on the money you borrow up front, right? Every year the same amount. That makes it linear. But with compound, that ain't the case. With compound, oh, you going to let your interest sit on here too? No problem. Since you ain't going to pay your interest up front or pay your interest as we go, I'm going to charge you interest on your interest because that money belong to me too. Are you following? Are y'all following? So let's keep going. What happens here? Let's do it again. What's going to be my interest right now? What am I putting in my calculator? 121. Come on. Times
11.
10 second 2. I'm doing 10%.
12.1.
10% of the 121. How much is that? $12 and what? And 1. It's okay. It looks like that sometimes. What is 01, right? $12 and what? 10 cents. Now, what is he gonna owe me at year 3?
130.
1. All y'all gotta do is press plus.
1.
Add these two together. What do we get?
133.1.
133 point what? 0.1, which is $133 and 10 cents. Is that the same or different? Different. So which one grows faster, simple interest or compound interest?
Compound.
Compound, because you're paying interest on not just the principal,
Paying
but
interest on it.
interest on the interest. Are you all following me? Yes? So now, I want to just show you this real quick, and then we're going to be done with this. Let's use this formula, because I know the bell finna ring on me. Work with me real quick. This is the compound interest formula. A equals, what was the principal that we borrowed? 100 times 1, all of the money back, plus, what was our rate? Still 10%, 0.10 over how many times am I collecting money from him? Once. So 1 time a year. That's that same 1 time a year. Now how many years? 3. So now we got A equals 100 times, well, 0.10 divided by 1 is just 0.10. So let me clean it up. 1 plus 0.10. Everybody agree?
Yes.
And then what's 1 times 3? It's just 3. I want you to look at this for a second. What kind of function is this? Is it linear?
No.
No. Is it quadratic?
No.
No, because it would be a 2. It is exponential. But we knew that because the exponent was a variable. If the exponent is a variable, it is exponential. Are y'all with me? Yes? So compound interest is what type of function? Exponential. Every time. All right? Let's finish this out. If we put this in our calculator, we'll have 100 times 1.10 to the third power. Y'all with me?
Yes.
Yes? And then we're going to do what? In the calculator, you're always supposed to do exponents before you do multiplication, right?
Yes.
So in our calculator, we're doing 1.10. Watch this button I press right here. Look at this under the off. Y to the X. Y'all see that?
Yeah.
That's the exponent key. Any exponent. I'm going to hit a 3 and press equal. That gives me 1.331. So 100 times 1.331. So I'm going to multiply that by 100 and bim. Look what it gives me. $133 and what? 10 cents. Isn't that the same amount we got on the table? Same exact amount. But we can jump all that if we just go straight to the formula. Are y'all with me? Key things we need to walk away with. Interest. There's 2 types. Simple, interest on the original amount, or compound, interest on the original amount plus interest on the interest. Are y'all with me? Which one is linear? Simple. And what is compound? Exponential. Everybody good? All right. I need all these papers passed up to the front, please.